Okay, today we are moving on, working on CO4, powers and exponents. You can find this in your textbook at 1.3, which is pages 13 and 14. So you'll notice that we are jumping around kind of in the textbook. So we're not going in the order of the textbook, we're going in the order of what makes sense according to the objectives order that we're doing. So we're at CO4. So a power is a way of writing repeated multiplications. A base is the base of a power is the factor, and the exponent of a power is the number of times the factor is used. So we have some examples of this, of the base with an exponent, and it shows the power. So we can see it's a little blurry on my screen. So that 4 to the 6. So 4 is the base. That little 6 up top is the exponent. And what it means is it's repeated multiplications. It's not 4 times 6. It's 4 multiplied by itself 6 times. So on your paper, you should write it out. 4 to the 6th equals 4 times 4 times 4 times 4 times 4 times 4. So you should have that written down, because a lot of times people see those exponents and they mean it's 4 times 6. So if it was 4 times 6, that would be 24. Look at what our actual answer is. We have 4 times 4, that's 16, times another 4, which would be 64, times another 4, which would be 100. Oh, sorry. I'm doing this too quick in my head. So that would be 266 times another 4 would be 426, 1064 times another 4. My goodness, that would be 16, 25, 4,256. Whoa. A lot different than the 24, right? So it's very important that when you see those exponents, you think to yourself, oh, I'm not going to fall for it. It's not 4 times 6. It's 4 times 4 times 4 times 4 times 4 times 4, 6 times. Okay, so you're multiplying that 4 out 6 times, not multiplying it by 6. Big difference. So let me move my screen up. So we did the 4 times 6. That would be if we see it as numbers. In algebra, we see it with the letters. So you could have that a to the nth power. And then somebody might say a equals 4, n equals 6. So you know it's 4 to the 6th power. So we would just say 4 to the 6th. If it was, let's say a equals 3, n equals, oops, I wrote it the way I wanted it, n equals 2, that would be 3, and we don't say to the 2nd power. With that 2, we say squared. 3 squared. So instead of saying to the 2nd power, when we read it out loud, we say 3 squared. Why? It's because when we square something, think of a square, the side times the side are the same. So all lengths of a square are the same size. So when you find the area of the square, it would be 3 times 3. The side times the side, they're the same. So we say it's 3 squared. All right. So here's another example that they put here. 2 times 2 times 2 times 2 would be 2 to the 4th because there are 1, 2, 3, 4 2's that we're multiplying. So it's 2 to the 4th. So here, if it's 7 squared, what would our answer be? What would 7 squared equal? What do you think, Maya?
49.
How did you get 49?
7 times 7.
Yeah, 7 squared would be 7 times 7. So there's 2 7's that we're multiplying. And if we know our math facts, we know that 7 times 7 equals 49. What would B be? 4 to the 3rd, or we could say 4 cubed. So when we see that 3 up there, it's called being cubed. So 4 to the 3rd, or 4 cubed, would be what? What do you think, Lily?
64.
Lily thinks 64. How did you get 64?
I did 4 times 4 times 4.
4 times 4 times 4. We have that 3 as our exponent, so we need to have 4 3 times. And she thinks that's 64. Let's check for math. 4 times 4 is 16. Times 4 more would be, that's 24. That is 64. Good job. So look at C. C is 3 to this. Is that a 1?
Yeah, that's a 1.
So 3 to the 1. What would that equal? Zoe? There's 1 3.
That's a hard one. That's
so
hard.
So if it's 3 to the 1, it's just 1 3 there. So your answer would be 3. Well,
What would happen with a negative?
so good question. If we had this as a negative 4 cubed, so that means we would do negative 4 times negative 4 times negative 4. So what's negative 4 times negative 4? It's a positive 16 because we had a negative times a negative. Now we multiply it by a negative 4. And it would be negative 64 because it's a positive times a negative. If it was negative 4 to the 4th, we would multiply it by another negative 4. So we multiply that by a negative 4. Now we have a negative times a negative, so our answer would be positive. So when you have a negative number, you have to be really careful as you're multiplying it out. Paying attention to, is it a negative times the negative? Did that turn positive? So this is a negative, so my answer will be negative. Please stop. When you're goofing around with Gregory, it's distracting me. Okay? So I could see what was happening and it was distracting me from my teaching. Thank you for stopping. So when you're multiplying out a negative exponent or a negative power, no, exponent, I was right. You have to be careful and you have to keep track of when it turns positive and then it turns negative and it alternates back and forth. So it gets trickier. Any other questions about that? That was a great question. All right, let's slide the paper up. All right, evaluate x squared when x equals 9. So do the math on your paper, see if you can come up with the answer. I see several of us with their hands up already. We're gonna give our friends a moment. So write it out. What would x squared when x equals 9? What does that expression look like? So what would the expression look like, Gregory?
It would be 9 times 9.
Yeah, 9 times 9, because we have a 2 here, so we need to multiply that in 2 9s. And if we know our math facts, what is 9 times 9, Nick?
Oh, 9 times 9 is 18. I mean, sorry, not 18. Sorry. 61. 61. No, sorry, 64. 64.
Oh man, we were putting you on the spot. So, shh. This is how easy it is to make simple mistakes in math. It happens to me, and it happens to you. It is super easy to make those simple mistakes in math. We go too quick. We've seen it when we've done our correcting, and you've seen some of my answers, and somebody goes, oh wait, that's not right. And I'll go, oh my goodness, I went too fast. So it's very important when you are doing your math that you slow down, okay? And just think about what you're doing. What is 9 times 9? Do you want one more try, Nick? Okay, 80.
81.
81. Okay, it's really easy to accidentally do 8 times 8. Okay, it happens. All right, so let's focus. B, evaluate B cubed when B equals 7. What will our expression look like? Regan. 7 times 7 times 7, because there's a 3 for our power, so we need to do it 3 times. So 3 times 7, or 7 times 7 times 7 would give me what? Answer, Nolan.
343.
Let's check Nolan's math. The first thing we're going to do is that first 7 times 7. We know from our previous question that was 79. 49. I wrote it correctly. 49 times 7. So 49 times 7, that's 63, that's 28, and that would be 24, so 343. Good job. So are we getting a good sense of how to work with our powers and exponents?
Yes.
So I'm gonna, our homework for today is our workbook pages that go along with 1.3. So pages 5 and 6. So I'm gonna stop our recording.